All right, so we have these questions asking us to differentiate these logarithmic functions, but also define a domain for the logarithmic functions. And so the first thing we're going to do is look at the graph of a standard logarithmic function, right? And first thing I'm going to say is like, if you have, like a coefficient in the front or like a fraction or anything like that, it's just going to be like a scalar of the function. It's not going to change it a whole lot, not anything too significant. But what you'll notice is, the with a coefficient or like a fraction in the denominator, it's just going to change the relative like size of the function, scale it up or down, but it's not really going to change it a whole lot, if that makes sense. But anyway, what you're going to want to notice is that you have a vertical asymptote as x approaches 0, and so x equals 0 is not defined by the logarithmic function. And the same goes for negative x values for logarithmic functions, which but you could have anything you want past 0. Like it can go as close to 0 as it wants and like as high as it wants in the x direction positively, and as close to 0 as you can get. It's that all that is fine. But so and then what that means is just the argument inside the ln function, whatever's in here, it always needs to be greater than 0 and cannot be negative, because that is not defined for logarithmic functions. It's not in the domain of definition. So first thing we're going to do, we'll start with this function on the left. So not only do you have to worry about the argument inside the logarithmic function, that x minus 1, but it's a fraction where this is on the denominator, or in the denominator with your x value inside the argument. So you're going to have to make sure this whole denominator also does not equal 0 for your original f of x function to be defined. So what you're going to want to do is set your denominator equal to 0 and then start solving for x. So you can move this over to the other side, just get rid of that negative, and then what you do from here is you can do what's called exponentiating both sides of the equation, which is a legal maneuver. You just raise everything entirely on both sides to the power of e. And then on the left, you'll have e equals 1. And the way e and the ln function work is they will cancel each other out. So those go away, and then you're left with just this. Not raised to any power or anything, just simply the inside of the argument, x minus 1. And then moving that 1 over, you'll have e plus 1 equal to x. So you'll know that when e plus 1 equals x, the denominator will equal 0. So for your domain, you'll have to have x is greater than e plus 1. And we can check by plugging that into the denominator. What was it? 1 minus ln of x minus 1. So if you plug in e plus 1 for x, you'll have 1 minus ln of e plus 1 minus 1 inside the ln function. And since all you have is addition and subtraction inside your ln function, you could remove those brackets and simplify out those ones, and you'll be left with 1 minus ln of e. And the ln of e is equal to 1. So then you'll have 1 minus 1 equal to 0. And that verifies that e plus 1 is the x value that will give you 0 in your denominator. So, looking at a domain now for your original function, your domain would just have to be, what is it, e plus 1? Let me double check that. Yeah, e plus 1, not included, to infinity. Because if you plug in anything bigger than e plus 1 into the ln function, then you'll get a positive inside the ln function, which is fair game. And, it doesn't matter if overall this whole thing spits out a negative number. It only matters if the inside of the ln function is greater than 0. So we're good there. Now, before we start solving derivatives, let's look at the domain for our other function. So this one's a little more simple. You don't have a fraction. You just have an ln function with an argument inside. So to find the domain, you just take the inside argument and set that equal to 0. And factoring out an x, you'll have x times x minus 2 equals to 0, which implies two solutions, x equals 0 and x equals 2. Those are two values that are going to give you 0 inside your ln function, which is not okay because we need values greater than 0. But then also looking at this, you'll notice this x minus 2. If you have, these two solutions to the inside argument that you found, looking at those, because those are your points of interest, you'll notice that, x minus 2, when corresponds with your x equals 2 solution. But then if you have this overall x times x minus 2, if you have an x value less than 2, like between 0 and 2, then you're gonna get a negative number out of this times like a small positive number, something less than 2. And then that will give you a negative number inside the argument of your ln function, which is also not okay. It's not defined in the domain of logarithmic functions. So then your domain will be that your x values have to be greater than 2, not including it, because anything between 0 and 2 is going to give you something that's not defined by the logarithmic function. But anything bigger than 2 is okay. You could see like in x times x minus 2, if you put anything bigger than 2 in for your x values, you'll just end up with a positive number, which is okay in the domain of your logarithmic functions. So that will be your domain. Now let's get into actually differentiating these logarithmic functions. This one is pretty straightforward. If you had something, say you have f of x equals ln of x, then there's no chain rule or anything. You just have the simple derivative of 1 over x. And you're basically going to do the same thing for stuff like this. You'll just have 1 over the argument of the logarithmic function, whatever's inside those little parentheses. you just have 1 over that, but then for something like this, you'll have to use the chain rule. So for this derivative, you will end up with 1 over x squared minus 2x, not changing the argument, but multiplying by the chain rule, which will be the derivative of x squared minus 2x, which gives you 2x minus 2. So final answer, 2x minus 2 over x squared minus 2x, which if you wanted to, you could factor the denominator as we did finding the domain. So you'll have 2x minus 2 over x times x minus 2. And now moving back to our first question. Did I hit copy? Moving back over to our first question. This one is going to be, what did I do? This one's going to be a lot of fun. Okay, that's not what we wanted to do. So let me just copy that. I don't know. There. Okay, so we have the function f of x is equal to x over 1 minus ln of quantity x minus 1. So the reason I say this is going to be a lot of fun is because notice you're going to have to use you have 2 options here. You could use the quotient rule. It's something like or no, they don't use y. Quotient rule, f times g1 minus g times f1. Do I have that backwards? I think I do. I think it's like f1 minus g, f1 times g minus g1 f over g squared. But there's also another option that's, since you use product rule so much, there is the option of, recognizing this as a quantity to the -1 power. Because either way you do it, this denominator is going to be a mess. You're going to have to recognize it as to the -1, and like either way, you still have to deal with that derivative. So I'm just going to choose to rewrite it as your f of x equal to x times 1 minus ln of x minus 1. And that'll be to the -1. Since it's in the denominator, it'll just have a negative exponent. And then this is now the product rule, which is a lot easier to remember, and I feel like is less prone to making mistakes, because it's a lot harder to do it the wrong way. Like I'm over here like, is that the quotient rule? Pretty sure, but so if you do it like this, then I feel like there's less room for error. That's basically what I'm getting at. So then you'll have this x as your f function, and you'll have this whole thing as your g function. And then, in my opinion, it makes it a little easier. So your f prime will just be 1 times your g plus your g prime times your f. I'm just going to write f first because that's out of the way. Then taking the derivative of that big nasty thing, first thing you're going to want to do is bring down that -1. Then you're going to have the whole entire thing, including that 1, in front of the ln function. you're going to have that whole thing just power rule it. But then since it's more complex or whatever, you have to hit it with the chain rule. So technically, you're kind of going to have to hit it with the chain rule twice. That's why I didn't want to do differentiation or quotient. I didn't want to do quotient rule. So then you took the derivative of the whole thing. Now you're going to take the derivative of the inside. Derivative of that 1 in the front, the constant is 0. So then you're just going to have the derivative of the negative ln of x minus 1. So you'll just have negative 1 from the negative sign in front of the ln over the argument x minus 1. And that's all good. That's standard. And then you're going to take the derivative of the argument of the ln function, which is this x minus 1. Chain rule that. Derivative of that, derivative of x minus 1, that's just going to be 1 from the x. So then it's really not too bad. And then if you want to simplify that a little, you drop that 1. It's whatever, or it's in the numerator, I guess. So you'll have that. From this negative 1 exponent, you could just leave it unexponentiated, move it to the denominator, plus you have this negative 1 right here is going to cancel with this negative 1. So really in the numerator, all you're going to have is x. So you'll have x over 1 minus ln of x minus 1. Okay. And then, this 1 is whatever. Didn't even need to write it, but it just showed that it's there. And then times x minus 1. Okay, wait. I almost made a mistake here. This is negative 2. So that whole thing, it's in the denominator. So you can drop the negative, but still include that 2 for the exponent. And then this, you'll just have multiplied in the denominator also as x minus 1. And in Calc 1, they're probably not going to ask you to simplify past this point at all. This would be fine for your derivative function. I'm just going to move this so we got more space. So you could have your final answer as this. That'd be fine. If you did, however, want to simplify it, I could show you that. Just put this in brackets. And you're going to get the lowest common denominator, this x minus 1 here. And then you're going to multiply both sides of this fraction by x minus 1 over x minus 1, which is basically 1. So, it's a legal move because that whole thing that's just 1. So if you multiply that through, you could just leave your denominator as this whole thing because you'll have the same denominator for both fractions. You're combining them. So your denominator doesn't change. You'll have the same thing over here as you do over here. And then you'll just do the numerators, which is multiplying this x minus 1 times that 1. 1 times x is x. Negative 1 times 1 is negative 1. And then over here, you're adding this fraction, and you got an x over there. X minus 1 plus x. So then, 2x, x plus x minus 1 over 1 minus ln of x minus 1. That is squared in the denominator times x minus 1 in the denominator. And then this would be your final answer. And yeah, as you can see, simplifying it didn't really get us anywhere. It's not much different than the final answer would have been if you didn't simplify it. Like, you can't cancel out this 2x minus 1 with this x minus 1. But So in this case, it doesn't really help whether you simplify or not. And simplifying, you can make a lot of mistakes, so I would advise you just leave it as it popped out. But some cases, it could help you if you're working with the function more for, I don't know, maybe like another section down the line. But if this numerator ended up being 2x minus 2, then you could factor out a 2 from the numerator and have 2 times x minus 1. And then you're getting rid of the addition subtraction signs in the numerator. And then in the denominator, you also don't have addition or subtraction signs that are outside of these brackets. So like when you don't have addition or subtraction outside of the brackets and you just have two things multiplied by each other here, two things multiplied by each other here in a fraction, then they were the same. You could just cancel out those x minus 1s. However, in this case, that was not the case. You were left with, oh, my eraser's not working. You're left with 2x minus 1. But yeah, hopefully that helps. It's probably a lot longer than you want to listen to me for.